Hi, today I'm coming with a new feature of ACM, the dynamic metrics for single node OpenShift clusters. When we think about an edge environment, probably the idea that comes to our mind is the usage of the constrained hardware devices or non-reliable low bandwidth connections. In that kind of environment, every CPU cycle and byte transmitted through the network counts. The platform observability usually are processes that are sending continuously data. That means that they are consuming part of our reduced network bandwidth. But now, with ACM and Single Node OpenShift, we can help to reduce this network load in our edge environments. Thanks to the dynamic metrics collection feature, ACM does not collect the single node OpenShift pod and container resources metrics by default. It will only get the data out from the single node OpenShift when the cluster reaches a specific level of resource consumption. And more than that, when the cluster resource consumption is consistently less than the threshold for a period of time, 15 minutes by default, this granular metric collection stops, saving again network bandwidth for our edge location. Let's start with the demo. Okay, let's take a look to our demo environment. We have here our ACM, which is installed on top of OpenShift, running on AWS, and I created an additional cluster, which is a single node OpenShift that I already import in our ACM. I also, of course, enable the observability tools as part of this demo. Let's take a look to the Grafana dashboards. So let's open, for example, the compute resources for node dashboard. Here we have the local cluster where ACM is deployed, and we can see that we are getting some data, some metrics out of it. But what happens when we try to check a single node OpenShift? We don't get any data here. But if we move directly into this single node OpenShift and check in Observe Dashboards, we will see that we actually are collecting data here. So we are not sending back data from this single node OpenShift into ACM, which we will be running probably outside of the edge location, which implies that we need to make use of the network. We're not sending back this data until some CPU and memory triggers that forwarding of the metrics to the ACM. I will now generate some CPU cycles in this single node OpenShift by creating first a new project, so namespace, which will be called CPU load test, and then create a deployment that will launch one pod that is using the CPU intensively. So let's create the workload. Now we have to wait 2 minutes. Why 2 minutes? Let me show to you. If we go to config maps and check the add-on observability, in the metrics allow list, we will see the actual configuration for this dynamic metrics collection. If we check what are the collection rules here for single node OpenShift usage, resource usage, for the single node high CPU, we have a rule that says that if the system is running for more than 2 minutes with more than 70% of the CPU, then it will send all these dynamic metrics back to the ACM. So let's wait a couple of minutes. So now that it passed more than 2 minutes, we can go to the overview and we can see here how we have an alert because more than 70% of the CPU usage has been triggered. And then with under these conditions, the single node OpenShift should have start sending back data to the ACM. So let's check that into the Grafana dashboards. And as you can see here, the data start coming in into the ACM just right at the same moment that the 2 minutes passed with the more than 70% of the CPU usage. So now I will remove the workload that we generated, the one that is consuming the CPU cycles, and we will wait more than 15 minutes so we can check how actually the single node OpenShift after those 15 minutes stops sending back data again, so start saving network bandwidth. After 15 minutes we can check that we recover the normal state with less than 70% of the CPU usage in our single node OpenShift. And if we move to the Grafana dashboards, and of course I refresh the page, we can see that we start getting the data when we reach the 70% of the CPU usage, and then after 15 minutes we stop receiving that data because the single node OpenShift is again in that normal state. In this demo, we have seen how the dynamic metrics collection for single node OpenShift ACM feature can reduce the required bandwidth of our edge solution, and how, at the same time, we don't lose the needed observability when things start going wrong. Thanks for watching, and see you the next time.